Going on, guys, in this video we are going to see an example on application of first order differential equation in mixing of concentrations. Now let's look at the problem right here. Here the question is asking a tank contains 1000 liters of brine with 15 kilograms of dissolved salt. Pure water enters the tank at a rate of 10 liters per minute. The solution is kept thoroughly mixed and drains from the tank at the same rate. How much salt is in the tank after t minutes? So here they are asking for the particular solution. If we find the particular solution, that's going to be the amount of salt after t minutes, right? Now in order to solve this one, you have to apply this differential equation, and if you want to put this one in standard form, it's look like this: dA by dt is equal to R1 minus R2, and here dA by dt representing the change of amount of salt with respect to time, and R1 represents the rate of salt in, amount of salt in with respect to time, and R2 is amount of salt out with respect to time. And that's what we have right here. This is dA by dt is equal to rate in of salt minus rate out of salt, same thing. Now rate in of salt can be calculated by multiplying the concentration and the rate of water flow. Rate out of also same thing, multiplying the concentration out by rate of water leaving. Now initially we have zero concentration because in the question they have mentioned that this is pure water, right? So when we have pure water, the concentration is 0, and the rate of water flow is 10 liters per minute, and that's why we put that one right here. And then we have to find the concentration out, but the concentration out they didn't mention in the question, but we can find out using the generic pattern. This is unknown, that is A of t is the amount of salt after t minutes. That's what we are interested in. And after t minutes, and then we have this 10 liters per minute because they have mentioned here mixed and drains from the tank at the same rate. So initially it's coming in with this, the water is coming with 10 liters per minute, and it's drains at the same rate, so it's leaving also with 10 liters per minute. So that's why we multiply by this one. So we divide the amount of salt with respect to time by the volume, 1000 liters, right? And that's how we got the concentration. And we have now plugged everything in this equation. Now let's go ahead and solve it. So this is going to become dA by dt is equal to negative A over 100, because 0 times 10, that's going to be 0, and 10 and 1000 cancels each other, we get 100 and A on top. And here we can see that this is a separable differential equation, so we can separate and integrate. Now let's bring the like terms together. First one, we can bring the a's to one side, so this is going to be 1 over a dA, and in the other side of the equation we are going to have 1 over 100 dt. Now we have to do the integration, and if we integrate both sides, this is going to be integration of 1 over a, it's going to be equal to ln a. So this is going to be ln of a is equal to negative 1 over 100, and 1 over 100 is a constant, so that's going to remain the same, and the integration of dt, that's going to give us t, and also we are going to put a constant right here. Now this is our general solution for this differential equation. Now to find the particular solution for this differential equation, we have to solve for this c, but we need some information, right? But if you notice the question here, they have mentioned initially we have 15 kilogram of salt in the tank contains 1000 liters of brine with 15 kilogram of dissolved salt, right? So initially we have this one, 15 kilogram of salt, so we can say that A of 0 is 15. This is helpful because we know the time is 0, and if you plug that one here, that's going to be 0, and here we are going to have C is equal to ln of 15. C is equal to ln of 15. So if you know this one, we can find the particular solution, right? Now let's go ahead and do that this side. Okay, let's delete this part. So let's continue this one right here. So we found out that C is equal to ln of 15. Now we can go ahead and plug it in this equation. So ln of 15, actually ln of A is equal to negative 1 over 100 t plus ln of 15. Now to bring this into standard form, what we can do is we can take e power both sides, and here if you take e power this one and in this side e power this one, this is going to become just a, because e and ln cancels each other, we will get a, and here this is going to become e power negative 1 over 100 t, not plus multiplication. This is the general mistake. When the power add, it will multiply, right? So e power negative 1 over 100 t multiplied by e power ln of 15, and here also we have e and ln cancels each other. So finally we end up with a is equal to 15 e power negative 1 over 100 t, and this is going to be the particular solution for this differential equation, and this is going to be the amount of salt after t minutes, right? That's the question is asking, how much salt is in the tank after t minutes. So this is the amount of salt after t minutes. We can say a of t, right? And that's how we do this kind of problems. I hope this helps. Thanks for watching.